Wonderful. I appreciate everyone getting back to your seats. I know the luncheon and the networking is probably the most enjoyable part for many of you. It was always for me. And so just as a reminder, that's why today's event is a two-part event. So tonight, starting at 5:30, and Yasmin told me there is not a hard end time. Sorry, Yasmin. So starting at 5:30 and going as long as it goes, we'll have a reception purely focused on that great conversation and networking that you all are doing. Everyone here is invited. Again, that's at 5:30 at the Voyager Space headquarters here in DC. The address will be in your invite or your email for the event, and we'll also give it to you later so you have it. But now that we're back from lunch, hopefully everyone had a great time eating and conversing and meeting new people. But now I want to introduce our next panel, really an incredible panel, incredibly exciting topic that is very emergent, again, very dynamic area. It's not something that we've had in prior years. And that panel is going to be led by Eric Stallmer, Executive Vice President for Voyager Space. Eric has been longtime friend, supporter, board member of Future Space Leaders Foundation. So thank you, Eric, and please bring your panel up.
Andre, Dave, Tommy, come on up. It's great when they lower the bar for us to start right after lunch and following Dr. Thomas Zabrukin, who just discovered like 5,000 galaxies this week. So, no pressure for this panel at all. But that's what we really thrive on is pressure in this environment. So I want to first, how I'm going to run it. We're going to have the panelists introduce themselves, talk about their company, talk about the program, the Commercial LEO Development Program that's going on that NASA put out back in November of last year, a great program to follow on to the International Space Station, get the buy-in of the commercial partnerships, very much akin to commercial cargo and the commercial crew program that has had just tremendous success with NASA and for the nation. So how do we bridge that gap of the International Space Station that is scheduled to go away, who knows when? We keep our fingers crossed, but 24, 27, could be 30. But we have 3 companies today that are ready to help bridge that gap and close that gap of what we do and how we operate and live, work, and play in the low Earth economy, low Earth orbit economy. So first, Andre, why don't you get us started? Tell us a little bit about what Northrop Grumman's doing. A little bit of background on yourself as well, just because we're here to influence people. Quick question, and I jump around a little bit because I've had 7 cups of coffee today. So I know there's a lot of different fellows here from a lot of different organizations. I think we have Matthew Yosakowicz, we got Brooke Owens, I heard the ZED fellows, not to mention congressional staffers, interns from across the country. So drawing a little bit of, I'm going to ping on you guys a little bit for experience. And we did, I think we got an F on diversity on our panel, all white males in dark blue suits. So that was a memo. That was not planned. We had a few cancellations, so I apologize for that. And they weren't going to wear blue suits. But because we have a wide variety of interns from all over, Brooke Owens, just one representative. How many different Brooke Owens fellows are this year's class? 50. So I talked to 7% of the Brooke Owens fellows. No, but more than that. Quick math here. 14% of the Brooke Owens fellows already just at lunch. So the challenge for all you guys, I say that proverbially, is to be talking to everyone. Talk to the different fellows out here. Talk to the mentors. Anyone over 24 is a mentor. They can be. So get out there and talk because there's a lot of experience and a wealth of knowledge out here. So with that said, Andre, give us the spiel. Tell us what Northrop Grumman is doing in low Earth orbit. I think so. Push to talk. You an engineer? If not?
And check again.
Yep,
there you go.
there we go.
Good. So hi everybody. So thanks Eric and Voyager Space for hosting us. My name is Andre Mitran. You're going to hear an accent. I'm from Romania originally. I came here when I was 16. U.S. Air Force for 20 years. Drove planes for a living. Good job. I saw a couple of uniformed folks there, so appreciate to see them. And after that, Northrop Grumman. So at Northrop Grumman, I work in Northrop Grumman Civil and Commercial. So you think of Northrop Grumman just like Lockheed Martin and some of other friends and compatimates. Lots of defense orientation, but we do have a strong civil alliance with NASA and NOAA, about 50 years of experience there, and a vibrant commercial unit. So about 21 countries, business to business with various entities. Anything from commercial satellites, mission and station vehicles, lots of LEO activity, lots of deep space activity. And specifically to this point, in our alignment with NASA, we are supporting the ISS currently, right, with a couple of elements, specifically our commercial resupply system. We have a spacecraft called Cygnus, and that spacecraft tends to come to the station about every 6 months, together with our friends at SpaceX the other time, right, with the Dragon. And wonderful experience there. We like to continue that, hopefully with some of our friends here when we start to commercialize the space station. In addition, we're supporting NASA's stretch into deep space. So Artemis, and you may be familiar, is our next leap going to the moon. In that regard, we are currently building the habitation and logistics habitat, which is essentially, think of Outpost, which is the first habitable element of a space station called Gateway around the moon, which kind of plays into a NASA strategy of pushing away from LEO into deep space and leaving LEO to the commercial, to the kind of the subject at hand here. So we're building that particular habitat. So together with Cygnus, together with our mission extension vehicles, it's a natural progression for us to now interact with NASA in trying to commercialize the LEO market. So we're very excited about that. It's very vibrant. Our strategic focus right now is understanding the market. What does that mean? How can we make it sustainable, and how can we make the pie bigger? So we're not so much focused at this point at what exactly we're going to do. We are manufacturers, but our exact role is secondary at this point to understanding how can we make LEO commercial so we can have NASA and other civil agencies move into deep space and eventually to drag humanity that way, kind of the expanse. Think of like the show in the book, it's happening now. Let's hope it's happening now. And from a macro strategy perspective, our company is very excited to support it. Very excited about strategic partnerships in that regards, and looking forward to the Voyager and certainly to the discussion at hand here in that regard. Back to you, Eric.
Oh, thank you so much, Andre. I'm going to turn it over to my friend and colleague, Dave Marsh at NanoRacks. Dave, why don't you talk a little bit what NanoRacks is doing and our plan for the future with Starlab?
Sure thing. Thank you, Eric, and hello, everyone. So my name is David Marsh. You can call me Dave. I work with NanoRacks, and I like to start off with a story of my first day at NanoRacks. A few years ago, I was an intern, so I show up my first day, and Jeffrey Manber, who was the CEO at the time, who now works at Voyager, slapped a book on my desk, told me to start reading and start studying. That book was Microgravity Research Opportunities in the 1990s, which I don't expect any of you guys to be familiar with that, but if you are, it's like a 150-page paperback that was put together by the Space Studies Board that summarized how do you do research in microgravity in the 1990s. If you were to write that book again today, it would be significantly longer than 150 pages, but I think that moment really, I should have realized that that moment was going to be basically symbolic of my entire career at NanoRacks. It's always been reading and studying what's going on in space, and more importantly, what has happened over the last 10, 20 years to bring us to this point. Currently, I'm the head of strategy at NanoRacks, which means that I take all of that research and figure out how we convert it into making decisions for how we operate a space station, how we conduct business in space in the future, and really how do we build an ecosystem of people who use space. Because it's not just about a station that you build, it's about the community and the people that you're working with, whether they're researchers, businesses, governments, whatever. Before I worked at NanoRacks, I was in consulting for a while, and then prior to that, I studied political science. So, not a scientist, many of you in here are. I think there's an important element here that social sciences are important for what we're doing in space. Many of you might be government relations folks or planning to move into that career. One of the things that's really fascinating about, or one of the things that I find particularly interesting, is the institution of the ISS, right? The relationships between countries that built it, how it's operated, what we can learn from it about what went well, maybe what's not going so well, and how we can improve upon it. So to that end, NanoRacks is, we've been working on the space station for decades. And we're extremely grateful to NASA for the trust that they've put in us to continue working with them on ISS. We've flown well over 1,000 payloads. Actually, 2 weeks ago, we deployed our 300th satellite from the International Space Station. We've worked with 30, 40 countries around the globe, hundreds of companies. Actually, we work with both the companies up here today, whether it's Northrop Grumman for the Cygnus spacecraft, or if we work with science payloads in the past. So we're extremely happy to be a part of a growing space ecosystem. You guys may have also heard about the Bishop airline, which is something we call the first commercial real estate on the ISS. We actually used it a couple weeks ago to deploy trash. So not exactly the most glamorous application of space technology, but it's something that needs to happen. I think that demonstrates an understanding that NanoRacks has of what it takes to live and operate in the space environment commercially. And so I think we've really begun an evolution from a space services company in the past to what we call a space station company. Bishop is kind of that first step, but the next iteration of that is something that we call Starlab. So for the past few years, we've been developing a concept for a commercially owned and operated space station. We proposed a version of that concept to NASA's Commercial LEO Destination program. We were successful, obviously, that's why I'm sitting up here. And we are now building this station in cooperation with our subcontractor, Lockheed Martin, who's going to build the station itself. But I think what's really important here is we're building this as a station that's designed totally around the user's needs and utilization, right? We're not building this to be a shining palace or a kind of a center for intergovernmental cooperation, which the ISS was, and it was extremely successful at that. But we're building it to ensure that people have a place to do whatever it is that they want to do in space, right? Whether that's students trying to do a research project, whether that's companies trying to develop technology, whether it's a government who's trying to continue doing their human research, whatever it may be. So that's kind of the guiding principle of our Starlab concept. As far as the station itself, you guys may have seen photos of it floating around. It's a large inflatable module, then a smaller metallic module, and then float solar arrays. Someone back there has a picture of it on their notebook. Excellent. And so I think what's important here is that we're building Starlab to have initial capability in just one launch. So we want to have something in space as quickly as possible that we can start using, that we can start offering to customers. Because as I'm sure you are all aware of, the ISS will not last forever. And other people have station alternatives in space today operating. And so the United States is facing a situation similar to the space shuttle, the political scientist is coming out here a little bit, where we face a space station gap, right? We are lacking in we may lack in critical capability. We need to make sure that we have a solution there. So NanoRacks is approaching this problem as, how do we get something in space as quickly as possible to get the job done with that initial capability? And that's what you see with our Starlab concept. So if all goes according to plan, we'll be launching at the end of 2027, and we'll be hosting crew on board Starlab in 2028. Starlab will provide services to a whole breadth of people, users, whoever they may be. But what's really important in addition to that station is an organization. I mentioned earlier, ecosystem. We're building an organization that we call the George Washington Carver Science Park. We chose to name this organization after Dr. Carver to honor his legacy as an American agronomist. Famously he developed over 300 commercial and industrial applications for the peanut. So not only do we think that agricultural technology is an important area for the LEO economy, but we want to honor his legacy and show a commitment to increasing space participation. People talk a lot about access to space, but it really is another level here, which is not just giving someone a place to go, right, which might still cost a fair bit of money, but giving a pathway for people to be involved. And so we're focusing on building that participation at the ground level with the Science Park, which will also be a terrestrial location somewhere in the United States, in addition to the actual hardware that's on Starlab. So we'll go into both of those a little bit more in depth, I'm sure, as this conversation continues a little bit. But at a high level, that's what we're trying to build here with NanoRacks. Looking forward to it. Thanks a lot.
Great. Thanks so much, Dave. And finally, Tommy Sanford. Tommy and I have a long, rich history together. Tommy and I worked together at the Commercial Spaceflight Federation for 6 or 7 years. There's very few people that know space policy better than Tommy and had more influence on a lot of the space legislation and the regulatory matters that came in front of Congress and the White House over the past 8 years than Tommy. And just a huge importance, especially in the areas of microgravity research, which, when you talked about that book, Dave, Tommy, if he doesn't already have 3 copies, he's going to want another and have a few more chapters to add to it. So Tommy's now at Blue Origin. And not directly working on the Orbital Reef program, but working in conjunction with Orbital Reef. So Tommy, why don't you give a little background on Orbital Reef and what you're doing at Blue Origin and how things are going, and a little bit of your background as well.
Great. Well, thanks so much. And note to self, never go behind David when it comes to speaking, because he's like the Dr. Zurbuchen of microgravity space. Very passionate and very put together. So next time I'm gonna move over at least one seat over. So thank you for that, Eric. I appreciate that. No, so. I see that. So as Eric said, I'm very excited to be working at Blue Origin. We're building the road to space from the von Karman line all the way to the lunar surface. And in doing so, we have a number of capabilities that we're doing that with. We're doing that first with the New Shepard suborbital vehicle, which is what I work on mostly day to day. I'm the New Shepard payload sales director, and I'm very excited to be working on the New Shepard program because it's the most capable suborbital vehicle in all of human history, and will play a significant role in opening up the access to space, which in doing a lot of the research on that space policy and history and being on the ISS National Labs independent review team for NASA, that was one of the key problems, was access to space and regular access to space. And we're already changing the game on that with adding 20-plus new astronauts to a very small group, which we're looking to make even bigger over the past year. So very excited to be working on New Shepard. We're also building New Glenn, which is the bigger, older sibling of New Shepard, and making great progress there. And then we have Orbital Reef that we're building, and a human lander as well. And the nice part is that in building that road to space, we can take you anywhere from, like I said, the von Karman line to the lunar surface, and it's a great place to be. So. I'll just give a quick overview of a few things on Reef, and then I'll do a little bit of background on myself. So with Reef, Orbital Reef is commercially developed, owned, and operated space station being built in low Earth orbit, and it's going to be operational by the late 2020s. We're working on Reef in partnership with Sierra Space, and we're teaming with members like Boeing, Redwire, Amazon Distribution and Fulfillment Solutions, Amazon Web Services, Genesis Engineering Solutions, and Arizona State University. And the key thing is, when it comes to Blue, is that opening up the infinite resources of space requires making spaceflight normal. Millions of people living and working in space first needs thousands, preceded by hundreds, and starting with dozens, and low Earth orbit is the key. So a couple of lessons learned that were from being from the International Space Station, and again being on the ISS National Lab independent review team, was that robust partnerships are key to sustainability, and robust access is key to sustainability in low Earth orbit. And we have built that in from the beginning, as I talked about earlier with some of our partnerships. But in addition to, and we've also built that in when it comes to our access to space. So we'll have New Glenn that we'll be flying. We'll have Sierra Space's cargo and human-rated vehicle, and then also Boeing's commercial crew vehicle. And to round things out, we'll also have New Shepard that will be able to provide access on a regular basis. And so we've really learned a lot of the lessons from the ISS in what made it sustainable, and building that into the Orbital Reef program. And then about me, myself, before I came to Blue, I spent almost 8 years at CSF with Eric, and there I worked on programs related to suborbital space, commercial low Earth orbit, and then the moon. And we got a lot of wonderful things done there. However, it aged me tremendously, and I am much grayer and have many more wrinkles on my forehead than a 37-year-old should be. But it was a wonderful experience, and it's amazing to be a part of what's happening now, and to really turn one's dreams into reality.
Fortunately for me, I had already lost the hair when we started working together, so it had a minimal impact.
Well, and I was 7 feet
That he got worn down. He got worn down. Andre, tell us the importance of why CLD and the Free Flyer. Why it's important to Northrop Grumman. Why did I think was there 12 or 14 companies that bid this? You guys were one of them. What made the difference for you guys?
Sure. So we've done some soul searching, whether we want to do it, right? It's always we're a publicly traded company, and we want to make sure we take net present value projects on board. So when we looked at this, a couple of things were important. At the strategic level, we do need to make the pie bigger in the space economy. LEO is the place where industry really makes sense to help our civil customers move forward. So there is a patriotic, good for humanity, an element there that this is somewhere we do need to push and to help. That's one area. Internal to Northrop, we like to say the space is hard. And what does that mean? What does that mean, space is hard? It means that the probability of failure is extremely high, and the most likely chance of success is through incremental innovation. So that you have radical innovation, incremental innovation. So incrementalism tends to produce success. 50 years of experience tells us that. So when we look at what we've done with Cygnus and how Cygnus continues to evolve into additional services besides cargo delivery and trash removal, very important, by the way. Trash removal is absolutely important, not to be underestimated. But besides that, now what else can we do with Cygnus? Cygnus is a free flyer itself, so we started using Cygnus for commercial and additional payloads besides NASA. We can use Cygnus to reboost or raise the orbit of the ISS. You may have seen that in the news, but essentially ISS is constantly sinking. There's still some atmosphere at about 450 kilometers up there. So we're using our spacecraft to control the ISS to a certain extent. There's a geopolitical element there, not to go into now. We're looking at using Cygnus for deep space travel, so on. So having that experience of Cygnus is a gradual incremental innovation to move now into producing Cygnus for additional customers, also producing Cygnus derivatives for maybe fuel stations, et cetera, if we're going to have a vibrant multi-station economy. Now, take Cygnus as a franchise. We've extended that into habitation, right? So that's the HALO acronym for Habitation and Logistics Outpost for Gateway. So that's essentially a mini space station that we're building right now, should get airborne or spaceborne in 2025. That's going to be obviously in deep space, dealing with some actually harsher, more challenging environment in most cases. But that experience, why not take that now and bring it into LEO? And we already have, again, a baseline from which we can develop additional habitation. And for us, it's essentially much like NanoRex. We're looking at the initial station to be one shot, just go up there, operational from the start, FOC within days of being airborne or spaceborne. But then we can keep adding Cygnus derivatives or modules to see what, based on demand, right? So there's an incrementalism into the building. So wrapping it up into why CDFF is important, there's clearly a global and a national interest there. And from a company perspective, it pushes us incrementally from what we're doing now into what we're going to do in the future. Again, helping us incrementally test. And let's get a little more specific and say space is hard, what are we testing? There are many things that ISIS has done wonderfully. And then there are many things we still have a long way to go before we can get to Mars or before we go into deep space. Much of that science development will still continue, much of that research inside either the Gateway, which is a little further out, or a space station near LEO. So that scientific progress is important. And then the second element is how do you scale up? So in order to make it an economy, you need to go from an experiment to scale. So that scalability is also interesting to us because another franchise that we have, which is the mission extension, mission robotic vehicles, currently do that in geosynchronous orbit, a little further out. Can we bring that into closer to orbit? Now we can start doing space for ground, space for space. Can we build things in space that actually, for some perspective, it's safer and more reliable than building something on Earth and upmass it with all the risks involved there? So that's a huge topic, right? But it's an element where a CDFF, a commercial destination free flyer, helps us further evolve both science but also an economic or a scalability aspect.
That's great. Thank you so much, Andre. Dave, I know this is a garbage question, but I got to ask it. So you did take out the trash last week, right? So what was your experience from, I don't want, cradle to grave is too clean, but the whole process of working with NASA with the airlock and the purpose of the airlock, and trash is just one of the opportunities that you have there. But as these three companies are going to be working with NASA as one of the principal, certainly as an investor and a tenant, what is some of the process and some of the lessons learned of working with NASA on this for the trash, and how do you see things moving forward?
Yeah, sure. So once upon a time, we had this idea that we need to have more airlock capability on the ISS, right? So there are a few other options. For various reasons, you can't use certain airlocks on the ISS for different things. One's controlled by the Russians, one of which, the Japanese Kibo module, is fairly small. So we identified a need for something larger. There was no RFP. NASA didn't say, we want somebody to build us an airlock. Can 10 companies compete for it? NanoRacks identified a need. We approached NASA and said, we want to build this. We believe there's a commercial use for something like this, and we're going to raise the money ourselves to do it. NASA said, okay, great, go ahead. And so obviously they were an important partner throughout that whole process. So thank you to NASA and the crew, especially for the trust and for helping us to actually execute the mission. So I think the first key piece here is it demonstrates the possibilities of commercially owned space hardware, right? When we built it, we didn't think that one of the first applications was going to be trash disposal, but very soon after it became clear that NASA had a need here, right? Cygnus is the other trash deployment option, but there's only so much that you can take down on 2 flights per year. And so we saw that need, we approached it, we figured out a solution, we worked with NASA to develop it. That's the first piece. I think the other thing here, if Andre's soundbite from his is space is hard, mine is going to be that the LEO economy won't be built in a day, right? This ecosystem is being built a single payload at a time, a single $100,000 to $200,000 payload at a time. It is not millions and billions of dollars suddenly appearing in this marketplace, right? And so NASA has seen that growth and helped to lay some of those bricks and fly 1,000 of those payloads over time. And so we've been able to show NASA that we understand what we're doing, right? Whether it's a single microgravity science payload, whether it's a student project, right? Or whether it's a massive bell jar airlock that you're using to deploy 200 kilograms of trash right off the Canadarm. So I think it's showing that breadth and showing NASA that we understand how to build that ecosystem, right? Also, it was pretty cool. We should be releasing some video from the deployment if you guys haven't seen it, and it's a pretty awesome image. Probably I've taken out the trash probably how many thousand times in my life. That was the coolest one for sure. But yeah, I think it's showing that we have that understanding of supply and demand and how commercial companies can operate in space that really demonstrated that to NASA.
I won't share that video with my wife to reinforce one more job opportunity for me at the house. So, switching from trash, Tommy, Blue Origin really understands the customer experience. From what I've witnessed firsthand, with the New Shepard launch, on launching the private astronauts, on the whole process, the customer service process that goes through, and the experience, I should say, that they have. How do you see that playing out in the future with New Shepard and with Orbital Reef? How do you see this customer service angle shaping and continuing in the great trajectory that you guys have already started?
Yeah, I appreciate that. So one of the things that we were looking to solve is that providing regular access, and then as well reliable return, and then also an ability to have the size and space that you need to go to. And sort of one of the issues today on the station that has shown a great insight into what's possible. There's been a lot of microgravity experiments where you could start to see what could become really amazing if you just had, this or that, or, you could scope it a little better. And so that's sort of one of the big things that we're trying to do with Orbital Reef, is that you can have those very specific needs met. And you can, so whatever the space is that you require, the power, for however long, is specially fitted to your needs and when you need to get there, and how often, and how often you need to come back. And we really do believe that that's going to be a significant difference maker in turning, again, what has been shown to be what's right around the corner that you could possibly be great, it could turn into something great, into actually being that thing.
Awesome. So I got a question, this is kind of a little bit for the group, and we're kind of delving into the geopolitics of the space stations. But the Chinese space station, the Tiangong, will be completed later this year. And they've welcomed international partners, and many countries have taken them up on their offer. How do you see this? Do you see this competing with American commercial space stations, competing for international business? Is that a threat, or is this a good opportunity for the three providers?
Yeah, if you guys don't mind, as the resident political scientist here. So I think the important thing here is we already know that people are going to use the Tiangong as an option. The UN actually did a project where a number of payloads from around the world competed for the opportunity to fly. I think they selected about 9 from Western Europe, South America, really the whole world, that will be flying on Tiangong here in a little bit. So it's already going to happen. They've announced that they want to participate with international customers and international astronauts. So a variety of deals have been made, and I think it's clear that people will use whatever option is available, right? Whether it's in the developing world, where there might be a little bit more of a stick influencing people about which space station they operate on, or whether it's Western Europe, because some of these countries want to develop that relationship. So I think it's almost a given that we will see more international cooperation on Tiangong. I think the important thing for all of us up here and everyone in the room is that we just need to provide an alternative, right? We need to provide an alternative, make sure that there's a consistent option, again, avoid that space station gap, but ensure that if there is a stick being offered to another country that wants to fly a payload to space, there's a carrot, and there's a better option available that's one of these CLDs, or it's the ISS. I think the other important thing here is making sure that the ISS program continues. Right, we've seen the risks to it, especially with the recent political developments, and making sure that that program continues and we avoid a space station gap is absolutely critical. But yeah, I think for us, we just need to be able to provide a better option for whatever's up there.
So just to add, to a certain extent, what's happening in LEO with the ISS and with space stations is a microcosm of the whole geopolitical and economic situation in the world, where China can be a force for good or not. And having a key question, underlying question there is how many, you may have that question coming up, how many space stations can a LEO economy bear? and let's just say that there's value in mass activity, LEO to LEO, which there's a great economic theory there. In that case, having a Chinese station, a couple of US stations, others, it's a good thing, right? So there is a lot of up-mass, a lot of collaboration. That's also predicated that this collaboration exists, that free markets exist. Unfortunately, sometimes that's not the case with the People's Republic. So that's where it can get, I'm not going to say dicey, but maybe not as productive for the end goal the way we perceive it. So in that regard, totally agree with David that we need to have a counter, and we need to offer options that are, in our opinion, superior.
Yeah, I'll just foot stomp on the 2 points that you made there, that increasing the number of options at a high level is good because competition among many providers is always best for the customer. But at a more tactical level, what that competition looks like is important. And if there are unfair subsidizations that go on, that undermines the competition in the long run, because they're intending to just run everybody out of business. And then once that happens, they jack up the price or the service becomes worse. So finding the balance between those two forces, I think, is the opportunity.
That's a great point. Hey, just a footnote, Dave. I think Tommy and I are also political scientists, but I would add, we did this big campaign to do STEM PS, like science, technology, engineering, math, and political science, but it sounded too much like STEM BS, so we dropped that. We just said that doesn't work well.
Social engineers.
Yeah, social engineers. That's more a thing. So getting back to the ISS a little bit, it's been up there for 20 years now. We've had a lot of operational experience on ISS. What do you guys, and from all the work that all the organizations have done on the ISS microgravity, what do you see as some of the essential lessons learned from the ISS? And it could be the international partnership and cooperation, things like that, and some of the challenges, and how have some of those challenges been overcome? Andre, you want to take that off?
Sure. So ISS has been a resounding success, right? A wonderful example let's bracket it into 3 areas. Many ways you can dice this, but from a technology development, just hardware, software, can it be done? It proved that it can be done, that this huge structure, 3 football fields, can exist in LEO, and it can produce, it can sustain life, it can do a lot of things. So that is a huge achievement, and the challenge here is through civil and commercial engagements to extend that in LEO and then beyond. So that was, I think, mission achieved. Secondly is just operations. So the Nanorex airlock, the Cygnus, how do you take something up there, coming back down? Crew, commercial crew, right? So ISS has been pivotal into that idea of creating something called kind of a critical design that what does a spacecraft and what does a habitation need to look like in order to be effective, right? And then, of course, the geopolitical aspect of cooperation in space has been promoted in the ISS. I think it's been a force for good. It's an inspiration to others. And that's also a fundamental success for the ISS. And on all these 3 arenas, you can look at ISS as being the baseline. And now that has been achieved. Okay, what do you need to do next in order to pursue our goals in the outer space, in LEO and beyond?
Yeah, so totally agree. It's been a resounding success. I think from my perspective, one of the most important lessons from the ISS is how the observatory model functions. So the observatory model is one way to think about the ISS, wherein countries and space agencies provide something, whether it's technology, personnel, money, launches, whatever. They provide something, and then they get a percentage of the utilization in return. So for the U.S. orbital segment, since the Russians have control of theirs, the United States gets 76.6%, JAXA gets 12.8%, ESA gets 8.3%, and the Canadian Space Agency gets 2.3% of total crew time and resources. That model works really well when you're working with governments because you have international treaties that govern that allocation, that govern how you exchange if somebody's not using their full allocation, what have you. So that's really good. It's straightforward. Everybody knows the rules. You can work within that framework. That model doesn't really work when you're dealing with commercial payloads and commercial users. Commercial companies really care about a couple things in space. This is speaking from NanoRac's perspective, and so it may differ from my colleagues here. But companies really care about consistency, right? They want to know when they're going to fly a payload, what the schedule is going to be, right? When they're going to get it back, when the research is going to be done. Because for a lot of these applications for microgravity research, pharmaceutical, biotechnology, what have you, that time matters, right? If you're a company competing for some new drug development or what have you, taking 18 months and having to wait an extra 6 months on the end of that because you're waiting for your return from the ISS can mean that technology or that experiment is viable or not. So companies need to be able to have reliable schedules, know when they're going to get their research back so that they can build that into their own models because they have investors and quarterly reports and things that they need to figure out. And then the second piece is intellectual property, right? Companies compete with each other. We're all up here competing with each other in some way. And so I think they need to know that whatever they do, whatever research they're doing or product they're developing on a space station is protected, whether that's they have total control of the intellectual property, which sometimes you don't have when you use government facilities on the ISS, and make sure that everybody else can't know what you're doing, right? So sometimes that's difficult if companies are looped into certain projects or everybody's aware of who's using which allocation, right? If you're a company competing, that can be it can be a disadvantage. So I think we've seen that the observatory model is incredibly successful for major government collaboration. The James Webb Space Telescope is another great example of something based on the observatory model. NASA provided components, ESA provided the launch on an Ariane 5, CSA provided personnel and resources as well. And now each of those organizations gets an allocation of the instrument time. They get to decide what JWST looks at and when, of course, according to the percentage of what they contributed. So that model's great, but we need to make modifications to that model if we're really going to create an environment where commercial companies, manufacturing, pharmaceuticals, things like that, can operate.
So I'll completely agree with the panel here that the ISS was a resounding success. But there were important lessons learned from our experience with the ISS, and one of the key ones was not relying on a single point of failure for critical transportation capability. The Columbia accident almost brought the ISS to an end just when it was getting started. And so that's one of the key lessons learned there. And I think that NASA and industry have learned that lesson. That's why you see multiple providers up here through development, and their plan is through ops as well. And then the other is, for us personally, we've also internalized that very well with having multiple providers in multiple ways to get to orbital reef, plan for our operations. And then the other lesson learned, I would say, is one that both we're learning from the ISS, but also we learned from the shuttle, which is the shuttle, just like the ISS, shows sort of what is possible. And for the shuttle, that was reusability, but it didn't bring all of the advantages that reusability was intended to bring about. And then commercial came in behind that, and having learned those lessons, and applied new ones, is reaping more of the rewards that the shuttle showed was possible. I think the ISS is doing the same, where it is showing what is possible. We aren't able to achieve all the things that we set out to, but that's where the commercial wave is coming in behind to learn the lessons learned from the ISS and applying those so that we can reap those rewards, just like we have with reusability in space transportation.
That's a great point, Tommy. So pivoting from ISS to CLD, a critical letter in ISS is the I, the international part of it. And if you're any one of the international partners, you're probably saying to yourself, what does this mean to us? What does this mean when station goes away, and what role can we play? So in your different programs that you're working on, what role are you doing to reach out to the international community and to say, hey, you have a place in low Earth orbit with us?
Can you guys hear me? Check, check. When we're approaching the market, we are really ambivalent to whether we discuss a potential business opportunity with somebody in Belgium or somebody here or somewhere else. There are some restrictions, of course. Additionally, we're in touch, obviously, with colleagues, not just from NASA, but from other nation-state space agencies, European Space Agency, Canadian, et cetera. And what's interesting that the civil nation-state agencies, they are our traditional allies, share the same perspective as NASA, that they would like to pursue commercialization, and they'd like to pursue commercialization in the context of homegrown entities and companies that would like to collaborate. So to a certain extent, and I think either Tommy or David mentioned that the strategic partnerships are absolutely important, so I couldn't agree more. And we, and I'm sure our colleagues, are doing the same thing. We're really looking across the globe to create these strategic relationships at business-to-business level, and then having discussion with international space agencies into where can we support their vision and their mission. So we're looking at supporting, much like we're supporting NASA as an anchor tenant, we can see the other civil agencies being additional anchor tenants to make sure this market survives, while we're bringing more and more commercialization and deliver to the space agencies a lower price point, perhaps ability for them to reorient their budgets into deep space, and in a sense, continued collaboration among those who are willing.
Anything to?
Yeah, so just real quick to add, I think there's two main points here to consider. The first is that it's not going to be the same answer for every country, right? Different countries, whether they're IGA countries, NATO, Five Eyes, what have you, they might have different concerns and different factors that are influencing how they would use a station like this. You know, if you're CSA, or if I was CSA, I probably wouldn't be happy with that 2.3%, right? I would be finding ways to increase my country's access to space and my participation. So that's the first thing, not going to be one size fits all. The second piece is for every payload that you actually see fly into space, the actual flight and flight operations are barely 10% of the total work that goes into it. The majority of the time and effort is spent on developing the technology, the underlying research, testing, retesting, designing, redesigning the payload and the technology itself. And so there's this whole, long tail backlog of work that needs to happen before you actually fly to space. And so in countries, especially in the developing world, where they may not have the same capabilities or the same ecosystem that exists in some of these IGA countries, we need to make sure that we're helping them develop that full ecosystem and make sure that we're not just showing them, hey, here's a place where you can pay, $500,000 to send a payload, or 60 million, 80 million, whatever, to send an astronaut. Here's a whole system to allow you to actually participate in space in a meaningful way. So I think that's important to consider as well.
Becoming a broken record here, I'd like to agree with my two colleagues on the panel. First, in the sense of the importance of the strategic partners and seeing that they are critical to the success of these platforms going forward. And then the other aspect being that there is no one-size-fits-all. And so whether it's a locker on orbital reef, or whether it's acquiring the services for a HAB for a year or multi-year, or whether it's plugging one of their own into orbital reef, we've got this mixed business park solution that allows for whatever their needs are to be involved in the solution.
So I want to be cognizant of our audience here. So if anyone has any questions, please feel free. Not the same number as when Dr. Zabrukin asked. I didn't see many hands, but we'll go right there.
Sure, yeah, I'll take this one. Great question. I mentioned a little bit about all of the work that goes into actually flying an experiment to space. All of that other work has to happen on the ground, right? We've also seen kind of a growth in analog astronaut and analog payload opportunities, ways for astronauts to, whether simulating microgravity or actually using equipment that's on the ISS so they can understand how their experiment's going to use that environment. Those are all extremely important. Right? There's so many little things that go into life and operations in space that you can only learn by doing. And so having those analog options available is extremely important. To sell our own solution here a little bit. One of the things that we're doing with the George Washington Carver Science Park is to actually have a terrestrial analog facility where we'll have a full mock-up of the station, actual equipment that researchers can use that's the same that they'll be using in space. They'll be able to sit there and watch the astronauts actually conducting their experiment. So, the astronaut can radio down and say, hey, we noticed something, what are we supposed to do about this? And the researcher is right there with them. So that ground link is always going to be extremely important, inseparable, really, because that research in space or the astronaut activity in space can't happen without that Earth element. So we need to make sure that we're making equal investments, so to speak, in those areas and make sure that those capabilities do exist, and also access. Make sure that people have access to them and can participate and be able to develop their own technologies.
So I'll give you a
Press it down.
So this is more of a 20,000 feet, right? To a certain extent, the more we engage in LEO or in space, the more we are eliminating the need for up and down mass. Which has a carbon footprint. There are a lot of negative effects there. So the more we can operate in that environment, the less we need to worry about some of those issues. Also, there's a lot of good things that we can do in space more efficiently. There you go. Perhaps more efficiently than on Earth, right? So biopharma being one. That's another example where we can benefit humanity through action in space. And also, as we expand activities in space, there are some beautiful opportunities for us to, let's go deep into the future, maybe 20, 30 years from now, grab an asteroid, mine it, not have to dig into the Earth. So there's a lot of substitutes which are, I think, are going to be very effective for humanity, very efficient for humanity, that we're stretching towards. You know, and I think that, to a certain extent, will be the greatest gain here.
So that's a great question. It goes to the heart of the vision of Blue Origin, which is millions of people living and working in space. And you can't have that if it's just the traditional folks that have always done space. You got to involve everyone else. And one of the data points that stuck out in my mind when I was on that independent review team was this quote from this researcher from Merck for pharmaceuticals that had really, he had gamed the system well, known it better than anybody else in getting to space, and still had struggles. And the quote was, I've been doing experiments in space for 24 years now, and I've flown 14 experiments over those 24 years. I can do 14 experiments in a day on Earth, and changing that is going to be a big key. So a part of that is having more options and redundancy and competition and all of that. But another way is, you won't be surprised by this answer, but the New Shepard capability of providing regular access. So maybe it's not at the price point or the time that it takes to get to space that a lot of folks are comfortable with dipping their toe in the water, but maybe a flight on a suborbital vehicle and flying with their experiment is. And building up over time, and it's not surprising that it is a stepping stone to LEO and the space station and space stations, that is a way to get over that hurdle, which is a key one. So again, I think having a group of competitors and a lot of different ways to get to space at a lower cost point is really going to be key to changing the way they think about it that way.
Great. I think we had one question right there.
Yeah, I'll answer that one real quick. So I think one thing to keep in mind is astronaut time is probably one of the most valuable resources off the planet right now, right? I think NASA charges about $160,000, $180,000 an hour for the use of that crew time commercially, right? That's insane. And if we're a commercial space station operating as a business, right, that's going to be a huge resource that we need to track and we need to allocate efficiently. So the extent that we can minimize the instances where that valuable crew time is used on very mundane things is extremely advantageous, right? Anything that we can offload telerobotically, offload that's totally automated, whatever we can do to make sure that that time is being used effectively is one of the most important things that we can do for our business models. So in short, yes, there will be a control facility from Earth. The exact extent to which things will be teleoperated, robotically operated, is still being developed. Unfortunately, robotic technology isn't quite to the point where I'd like it to be, but that's a resource that we have to keep in mind and make sure we use efficiently.
I would say one precedent, if we're looking at operation of Cygnus, is initially we are mimicking NASA with some significant continuous operation when our spacecraft is docked to the station, and also when it's on orbit after or before docking with the station and before reentry. And you know, the winds of creative destruction of capitalism has forced us to look at cost savings. So you always want to design something. Obviously, safety is first, right? That's absolutely you have to achieve. Then effectiveness, right? You want to make sure that you are effective. And after that, you want to bring a little bit of efficiency, and that's going to help you with your bottom line. I think that's where commercial is absolutely important to space. And in our experience, we started essentially reducing the staff in certain times of lull. And I'm not going to tell you how much, but we did achieve cost savings and also staff reallocation savings because of that, because that was important to us. So I presume with all our colleagues, the same thing is going to happen as we operate space stations in the future, that you're going to see a lot of efficiency. We better see a lot of efficiencies that's going to help us essentially cost effectively promote an economic development.
all afternoon if we wanted to, but fortunately, there's another panel on after us. So I want to thank Tommy, Dave, Andre for the input. Thank you for the great questions. If you have more questions, they're here. And I just want to make sure to plug the reception this afternoon, 900 19th Street, rooftop. Should be fun for all the Brooke Owens folks. I think you'll get a little dispensation if you stop there first and then go on to your next event. So hopefully. Okay, that's it. Brad, it's all yours.